Have you ever wondered what the universe looks like when everything finally grows still? Not the planets we see, not the stars we name, but the deeper spaces, the ones where light drifts slowly, where worlds move in silence, and where time stretches so gently you can almost feel it breathing. That's where we're going tonight. Into the quiet architecture of our solar system, into the subtle cosmic truths that shape our days and whisper softly through our nights. Hello, and welcome to Sleep Quotes Lab. I'm really glad you're here tonight. Let this be your quiet moment to unwind. Wherever you are, slow your breathing, soften the sounds around you, and let your thoughts float down like leaves on a still pond. If these peaceful stories bring you a little comfort tonight, feel free to like, comment, and subscribe. It quietly helps more sleepy souls find their way here, and it truly means the world to us. Let's start. Beneath our feet, the planet is restless in a useful way. Our continents ride on plates that drift, collide, and sink, carrying mountains up and old rocks down into fire. This slow recycling regulates our climate over geologic time and keeps the carbon flowing. Imagine continents as slow dancers, stepping, turning, creating new shapes across millions of years. No other known body wears this particular habit. Plate tectonics is one of the many soft miracles that have helped shape Earth into a place where oceans stay and life finds room to grow. Even the smallest rocks can have partners, asteroid moons. Not every moon is a grand world like our own. Some are tiny companions clinging in orbit around small, irregular asteroids. The first discovery of such a pair changed how astronomers pictured the belt of rubble between Mars and Jupiter. These are not only solitary wanderers, but small systems, miniature gravitational families. Imagine a lonely rock in the black, and then picture a smaller stone looping around it, slowly and patiently, a tiny dance held together by the faintest tug of attraction. Mercury's atmosphere is a whisper, an exosphere. Closest to the Sun, Mercury endures extremes, scalding days, freezing nights. It does not hold a thick, warm blanket of air, but instead wears a thin, ghostly shell of atoms called an exosphere. These are stray particles, sodium, potassium, the occasional bit of oxygen, knocked off the surface by micrometeoroids or the push of the solar wind. They don't collide and stir as they would in a true atmosphere. They simply drift and escape, forming a temporary shimmer that is replenished and lost again. Think of it as a breath the planet takes and lets go, a delicate halo that glows faintly to instruments but would be invisible to the naked eye. The sun trades mass for light, a patient shedding of itself. At every second, the sun transforms more than 4 million tons of its own mass into pure energy. In its core, hydrogen atoms fuse into helium, and in doing so, release the light that warms the planets and allows life to breathe. This loss is a tiny fraction of the sun's enormous mass, only a whisper across its long lifetime. But it is a constant sacrifice that keeps our system luminous. Imagine each second as a small offering of heat and light, stitched into the long story of our solar family. Saturn's rings are gorgeous and vanishing. Look at Saturn, and you see a halo of glittering bands that seem permanent, like a crown. Yet those rings are transient, flowing slowly inward in a subtle process called ring rain. Particles spiraling toward the planet, dragged by gravity and electromagnetic nudges. Cassini taught us that the rings may be surprisingly young, hundreds of millions, not billions, of years old, and that one day they may be gone. There is a quiet melancholy in that fact. This magnificent spectacle is a momentary flourish in a planet's long life, a delicate, sparkling phase that will slowly fade. The Parker Solar Probe is touching the sun. Humanity has sent a spacecraft straight into the sun's outer atmosphere. Protected by a glowing heat shield, it dips closer with every orbit, sampling solar wind, magnetic waves, and the hidden rhythms within the corona. It moves faster than any object humans have built, flying through a star. Some meteorites on Earth came from Mars. Blasted by ancient impacts, pieces of Martian rock wandered through space for millions of years before falling onto Earth. Inside, tiny bubbles of Martian air remain sealed like small glass memories, carrying stories of a world far away. The sun is mostly hydrogen and helium. These simple elements forged every bit of warmth and light we know. A reminder that complexity, oceans, life, thoughts, dreams, can rise from simple beginnings under the right conditions. Earth's tilt gently rights our seasons. A 23.5-degree lean is all it takes to create spring blossoms, summer heat, autumn colors, and winter storms. Without that tilt, life on Earth would feel strangely uniform. No drifting seasons, no changing light, no variety in climate. Jupiter's magnetosphere is the largest structure in the solar system. Stretching millions of kilometers into space, it is so vast that if it glowed like neon, it would outshine the sun in Earth's sky. Within it, charged particles swirl with immense energy, creating auroras and storms on Jupiter's moons. The stunning rings we see around Saturn today may one day disappear, a shimmering moment in a planet's long life. The moon's face barely changes across ages. Without wind, rain, or active geology, its surface preserves footprints, crater rims, and dust patterns for countless lifetimes. It is a silent witness to billions of years. Hidden hydrothermal vents may exist on icy moons. In the oceans of Europa and Enceladus, warm, mineral-rich water may rise from rocky seafloors, just like the vents on Earth that support entire ecosystems without sunlight. These dark oceans could be the best places to find life beyond Earth. Mars sometimes dresses itself in dust. Mars is not a frozen tomb, but a restless neighbor. Colossal dust storms can rise and wrap the whole planet, hiding its surface for weeks or months. Fine, rust-colored particles hang in the thin air and travel enormous distances, reshaping dunes and dimming the light that reaches the ground. Imagine an entire world veiled in red haze, where the familiar features of valleys and volcanoes blur into a slow, moving portrait. A reminder that even small grains of dust can carry the force of change on a planetary scale. Neptune wears supersonic winds. Far beyond the warm ribbon of our sun's closest companions, Neptune spins in the dark, where the sunlight is faint and cold. There, the atmosphere sings with ferocity, winds that race at more than 2,000 kilometers per hour, faster than sound on Earth. Picture pale blue clouds stretched into vast bands, and storms whipped into long, elegant shapes by an invisible hand. These are winds born not from sunlight, but from the planet's own slow, deep heat, an internal restlessness that keeps Neptune alive with motion, even in the farthest reaches. Imagine a quiet planet with a hidden, roaring heart. That contrast is part of Neptune's strange, serene beauty. Vast canyons carve a silent history on Mars. On Mars, the landscape keeps records written in stone. Valles Marineris yawns across the equator, a canyon system so wide and deep it could swallow whole countries and still hold more. In places, it drops down kilometers and kilometers, a scar that speaks of stretching crust and volcanic temper. Unlike Earth's river-carved gorges, this is a planet's skin, pulled and broken by forces that are slow and ancient. If you let your mind move along its rim, you can almost hear time flowing, deep, patient, and inevitable. Each layer, a quiet chapter of a world that was once far more volatile than the silent deserts we now glimpse. Venus, similar to Earth, and yet heartbreakingly different. Venus is a world that looks, at a glance, like our sister, nearly the same size, heavy and round. But here the story changed. Venus gives almost nothing the protection of a global magnetic shield. Its core does not roar the way Earth's does. Without that invisible armor, the solar wind chews at atmosphere and surface alike. Imagine a place where bright clouds hide a furnace beneath, where a world that might once have been temperate turned into something of endless simmer. Venus feels like a reminder that small differences deep inside a planet can ripple outward into utterly different destinies. Deep inside Uranus and Neptune, diamonds might be falling like rain. This is one of those images that tastes like a dream. On the ice giants, under crushing pressure and heat, methane could break apart and recombine into pure carbon crystals, diamonds. In laboratory recreations, carbon under those conditions can form dense crystalline structures and fall through layers of exotic atmospheres. Now picture storms of glittering fragments tumbling through deep blue or green depths, tiny gems drifting in a world of pressure and slow, patient darkness. It's not Hollywood. If it happens, it is an alien sort of weather, subtle and slow, and utterly beautiful in its quiet rarity. Beneath Europa's ice, a hidden ocean may breathe. Under a crust of cracked, gleaming ice, Jupiter's moon Europa likely shelters a vast, salty sea, warmed by the tug of its giant host. The moon's surface tells the story in lines and ridges, frozen scars of ice flows that shift, slip, and collide. Tidal flexing keeps the interior warm enough that liquid can persist. Picture an ocean sealed out of sight, stirred by hidden currents, a place where chemistry and energy might mingle in ways akin to the deep oceans of Earth. The idea of a hidden sea beneath a frozen shell expands the quiet possibility of life in places that seem, at first glance, utterly hostile. Olympus Mons rises like a sleeping titan. On Mars sits Olympus Mons, a volcano so vast it would swallow many of Earth's mountains whole. Nearly 22 kilometers high, its flanks are gentle slopes built from repeated eruptions over eons. Because Mars lacks the shifting plates that walk volcanoes across the surface, a single hotspot could feed one enormous mountain for millions of years. Let your mind imagine standing at its base, an impossibly broad plain under a thin, dusty sky, and feel the patient immensity of geological time. Saturn's rings are thin as a whisper. From afar, they look thick and solid. Up close, Saturn's rings are astonishingly paper-thin, often less than 100 meters thick, across hundreds of thousands of kilometers. They are made of countless icy particles, each following its own tiny orbit. When sunlight slips through the ring plane, they nearly disappear, a translucent veil rather than the solid band our imagination paints. There is delicate choreography here, shepherd moons, gravitational resonances, and tiny collisions that carve gaps and waves. The rings are a fleeting, fragile sculpture in motion. Earth is dense, compact, and rich inside. Compared to other planets, Earth packs a lot of mass into its volume. That density comes from a heavy, metal-rich core and a layered mantle, a compact interior that helps generate our magnetic field. That magnetic shield deflects charged particles and has been one of the planet's long guardians. In the quiet of our nights, remember that beneath our feet, a molten world hums with currents that do more than move rock. They help cradle the conditions life relies on. The sun sings with hidden waves. Though we cannot hear it with ears, the sun vibrates. Pressure waves ripple through its blazing body and create patterns of motion on its surface, a kind of stellar music. Scientists read this music to peer inside the star, mapping flows and hidden layers the way geologists use earthquakes. These oscillations whisper the sun's secrets, how its interior moves, where it churns, and how magnetic fields braid through its plasma. Venus turns to its own slow drum. Unlike most planets, Venus spins the wrong way, a slow retrograde rotation that makes the sun rise in the west. One day on Venus, one full spin, lasts longer than 1 year there, one orbit. Imagine a world where a single sunrise and sunset takes months, where atmosphere and surface trade heat in an eternal, sluggish waltz. This backward, languid spin is a quiet oddity that hints at dramatic events in the planet's deep past. Jupiter is king of moons and hidden heat. Jupiter rules a retinue, more than 90 moons of many sizes and stories. Its 4 Galilean moons are worlds unto themselves: volcanic Io, oceanic Europa, giant Ganymede, cratered Callisto, each unique. And Jupiter itself glows with leftover heat from its formation, emitting more energy than it receives from the sun. This internal warmth powers storms and bands, giving the giant planet a restless, lively face even in the dim light of the outer system. Radar reflections and spacecraft measurements revealed these cold refuges, places where ice can persist for eons, sheltered from the relentless solar glare. It's a small, poetic paradox. Ice preserved in the heart of a world baked by the sun. Pluto keeps secrets beneath its heart. Far beyond the planets, the dwarf world Pluto shows a bright, heart-shaped plain, Sputnik Planitia, whose geology hints at a possible subsurface ocean. Even worlds at the cold edge of the system may hold warmth enough to keep hidden liquid layers moving under an icy shell. It's a gentle reminder that warmth and motion can persist in the loneliest reaches. The asteroid belt is mostly empty. Contrary to the drama of film, the asteroid belt is a vast, mostly empty place. Objects in it are separated by enormous distances. Flying through would be a quiet glide past lonely rocks rather than a frantic dodge. The belt's total mass is small compared to a single moon, a scattered archive of planet-building leftovers rather than a continuous wall of rock. Uranus rolls like a tipped top. Uranus lies nearly on its side, tilted over so far that it essentially rolls along its orbit. Each pole faces the sun for long seasons, decades of daylight followed by decades of night. This extreme tilt shapes strange seasons and a subtle, somber beauty. A planet that orbits like a slow rolling wheel. Jupiter's magnetism is a cosmic reach. Jupiter's magnetic field stretches millions of kilometers into space, capturing particles and carving radiation belts so intense they would quickly disable an unshielded spacecraft. These invisible forces shape auroras and charged environments, making Jupiter not only visually magnificent, but also magnetically formidable. The Sun holds almost all the system's mass. The Sun carries over 99.8% of the mass in our system. It binds planets, comets, and dust in its gravitational embrace and drives the rhythms of orbits and seasons. Everything we see and everything we are revolves around this massive, steady heart. Pluto and Neptune dance without collision. Pluto's orbit sometimes brings it closer to the Sun than Neptune, a situation that occurred from 1979 to 1999. Yet the two never collide. Their orbits are locked in a gravitational choreography, a resonance that keeps their paths in a safe, waltzing distance. The solar system's stability often hides elegant balances like this, quiet mathematical dances that last for eons. A star's life ends in ember and silence. In roughly 5 billion years, the Sun will swell into a red giant, shed its outer layers in a glowing shell, and finally settle as a white dwarf, a dense ember the size of Earth that slowly cools over unimaginable time. It's a far-off fate, but imagining it gives a calm perspective. Even stars are born, live, and fade in long, beautiful cycles. Titan keeps lakes made of methane. Saturn's largest moon, Titan, is shaped by chemistry that feels like a dream. Instead of oceans of water, Titan's shores are carved by liquid methane and ethane, cold rivers flowing in slow, glassy currents. Thick, nitrogen-rich air forms clouds that drip methane rain, filling lakes and carving alien coastlines. Beneath its icy crust may lie a warmer, salty ocean of water, hidden from the frigid surface. Titan is familiar in shape, lakes, storms, shorelines, but alien in substance, a mirror world where the rules of Earth are rewritten in cold, soft hues. Mars' tiny moons may be captured wanderers. Phobos and Deimos, the small moons of Mars, do not resemble traditional round satellites. They are uneven, lumpy bodies that look almost like passing asteroids. Many scientists believe that is exactly what they are, ancient fragments pulled into orbit long ago. Phobos is slowly spiraling inward, inching toward its eventual breakup or fall into Mars, while Deimos drifts the other way, slowly escaping. They are quiet relics, unassuming companions that carry the memory of a chaotic solar childhood. Jupiter glows from within. Unlike most planets, Jupiter emits more heat than it receives from the Sun. Its immense mass is still gently contracting from its formation, releasing warmth from deep inside. This inner glow fuels its enormous storms, its swirling belts, and its lightning-laced tempests. In infrared light, Jupiter is not a cool gas giant. It shines like a slow-burning ember wrapped in shimmering clouds. Imagine a world that, if it had been only a little more massive, might have ignited into a star. Neptune was first found through mathematics, not eyes. Before anyone ever saw Neptune through a telescope, its existence was predicted by the subtle misbehavior of Uranus. Something tugged on Uranus's orbit, something heavy and unseen. Astronomers used calculations alone to pinpoint the hidden planet. When telescopes finally aimed at that predicted location, Neptune was waiting there, exactly as the numbers foretold. It was the first planet discovered by logic and gravity rather than sight, a quiet triumph of human curiosity. Saturn's North Pole holds a hexagon of storms. High above Saturn's atmosphere spins a vast, perfectly shaped hexagon, a jet stream pattern so large it could swallow Earth with room to spare. Its 6 straight sides form naturally from waves in the atmosphere, a geometry born of rotating fluid. Despite its alien appearance, this shape has persisted for decades, perhaps centuries. Imagine looking down on a planet and seeing a storm shaped like a mathematical symbol, precise, elegant, and endlessly turning. The sun's outer atmosphere burns hotter than its surface. It seems backward, but the sun's corona, its glowing outer layer, reaches temperatures of over 1,000,000 degrees, far hotter than the surface below. The reason is still being studied. Magnetic waves and tiny solar explosions may transport intense energy outward. This means the light we see each day is simply the visible surface of a much more mysterious system, a star whose outer layers blaze with unexpected heat. The Kuiper Belt holds frozen worlds. Beyond Neptune stretches a broad realm of icy objects, remnants of early solar history. Some are spherical, like dwarf planets. Others are irregular, tumbling through cold darkness. Pluto, Haumea, Eris, Makemake. These bodies are ancient archives of the first materials that formed the planets. Out here, sunlight is faint, colors are muted, and time moves slowly. These worlds drift like silent beads on the edge of the sun's influence. The Oort cloud is a distant, icy halo. Far beyond the Kuiper belt lies a hypothetical shell of trillions of icy bodies, the Oort cloud. Though we've never seen it directly, long-period comets hint at its existence. This cloud may stretch a full light year from the sun, marking the deep boundary of our solar system's gravitational reach. Imagine a vast sphere of frozen fragments, quietly circling in darkness for billions of years, occasionally sending a comet inward like a messenger from the ancient past. Io is restless fire in the cold. Jupiter's moon Io is the most volcanic world we know. Its surface changes constantly, reshaped by eruptions of molten sulfur and rock. Tidal forces from Jupiter squeeze and stretch Io like a beating heart, creating internal heat that bursts to the surface in violent fountains. Imagine plumes rising hundreds of kilometers into space, painting the moon with yellows and reds. It is a world of fire, surrounded by ice giants and cold vacuum. A strange, vivid contradiction. Triton moves in reverse. Neptune's largest moon, Triton, orbits backward, opposite the direction of Neptune's rotation. This odd behavior hints that Triton is a captured object, a wanderer pulled into orbit long ago. Its surface bears signs of cryovolcanism, geysers that spew nitrogen frost instead of molten rock. Triton is a moon that whispers stories of migration, capture, and upheaval, moving against the usual flow like a dancer turning slowly against the music. Earth's moon is unusually large. Relative to its planet, our moon is enormous, a quarter the width of Earth. Most moons around rocky planets are tiny by comparison. The leading theory suggests our moon was born from a colossal impact billions of years ago, when a Mars-sized body collided with young Earth. The debris gathered into a glowing disk and eventually formed the moon. That impact shaped our tides, our climate, and even the stability of Earth's tilt. Our moon is more than a companion. It is a scar shaped into a world. Planetary orbits aren't perfect circles. Although often drawn that way, planetary paths are slightly stretched ellipses. This means each world has moments when it is closer to the sun and moments when it is farther. For Mercury and Pluto, the difference is dramatic. For others, subtle. These elliptical orbits create seasonal variations and speed changes. Planets travel faster when closer to the sun, slower when farther away. It is a gentle, repeating rhythm built into the solar system's design. Comets can come from the edge of interstellar space. Some comets, visited by telescopes today, may have spent billions of years drifting in the darkness of the Oort cloud before being nudged inward by distant stars or galactic tides. They arrive suddenly, glowing with tails of dust and gas as sunlight warms them. These brief appearances are windows into the raw materials that shaped our system. The sun will one day become a white dwarf. In the distant future, the sun will expand into a red giant, shed its outer layers, and leave behind a dense white dwarf, a glowing ember made of compressed carbon and oxygen. For trillions of years, it will cool in silence. Imagining this distant future reminds us that even stars follow long, elegant arcs of birth, life, and resting. Mars carries seasons just like us. With a tilt much like Earth's, Mars experiences spring, summer, autumn, and winter. Its thinner atmosphere and greater distance make the seasons colder and slower, but the rhythm is there. Polar caps growing and shrinking, winds shifting, temperatures rising and falling. In this gentle similarity, Mars feels less alien, a quiet cousin with familiar cycles of light and shadow. Ganymede is a moon the size of a small planet. Larger than Mercury, Ganymede hosts its own magnetic field and likely carries layers of subsurface oceans between sheets of ice. Auroras shimmer at its poles, and cracks etch its surface like old stories carved into stone. In the quiet dark around Jupiter, Ganymede is a sleeping world full of potential and unspoken depth. Pluto and Neptune perform a cosmic dance of avoidance. Though Pluto's orbit sometimes dips inside Neptune's, they never meet. Their motions are locked in a resonance, a predictable rhythm that keeps them safely spaced. It is a gentle reminder that even in apparent chaos, the solar system holds hidden harmonies. The sun flips its magnetic field like a slow, cosmic breath. Every 11 years or so, the sun undergoes a magnetic reversal. Its north and south poles switch places. It's not violent to watch, nor even visible to the eye, but the effects ripple outward. Solar storms intensify, sunspots flare and fade. Auroras on Earth grow brighter and more frequent. This cycle is a kind of heartbeat, a magnetic inhale and exhale that reminds us that even stars are alive with rhythm, pulsing quietly across the solar system. Planetary alignments are beautiful but harmless. It's easy to imagine that when several planets line up, something dramatic must happen. But gravitationally, they have almost no effect on Earth. The pull of distant giants is tiny compared to the influence of our moon. Alignments are elegant mathematical events, lovely to witness through a telescope, but empty of danger. They are not omens, only choreography. Leaving the solar system takes decades of patience. When Voyager 1 launched in 1977, it began a journey so long that no one alive today will see its final chapters. Traveling over 60,000 kilometers per hour, the spacecraft took more than 40 years to break through the boundary where the solar wind fades, the heliopause, and enter true interstellar space. Imagine that. A human-built object carrying messages of oceans and birds and laughter, now drifting beyond the sun's protective bubble into the ancient quiet of the galaxy. Earth's magnetic field is our invisible shelter. Generated by molten iron swirling in Earth's outer core, our magnetic field forms a protective cocoon around the planet. It deflects harmful solar particles and shapes the auroras into shimmering curtains of light. Without this magnetic shield, our atmosphere could be stripped away, much like Mars. Even now, while you rest, this invisible blanket is guarding the world, loyal and constant. The moon slowly drifts away from us. Each year, the moon slips about 4 centimeters farther into space. At first glance, it's almost nothing, but across millions of years, it changes everything. Long ago, the moon looked huge in Earth's sky. Long from now, total eclipses will disappear as the moon appears too small to cover the sun. The sky is always changing, even if we never notice it. In the Kuiper Belt, some icy bodies shine like mirrors. Out beyond Neptune, icy worlds such as Haumea and Eris reflect extraordinary amounts of sunlight, more than fresh snow. Their surfaces are coated with crystalline frost, perhaps renewed by impacts or cryovolcanic activity. These distant objects gleam faintly in the cold, a scattering of cosmic mirrors catching sunlight that has traveled billions of kilometers to reach them. Enceladus breathes water into space. Saturn's small moon Enceladus hides a subsurface ocean warmed by tidal forces. Through fractures near its south pole, it releases geysers of water vapor, salts, and organic molecules that spray into space like shimmering fountains. Some droplets fall back as snow, some escape and become part of Saturn's E-ring. These plumes are among the most promising signs of a place where life could exist, a tiny moon whispering its secrets into the dark. Some asteroids are fragile rubble piles. Not all asteroids are solid rock. Many are loose clusters of fragments held together only by gentle gravity. These bodies spin oddly, shift under pressure, and can deform with even mild impacts. Spacecraft visiting these rubble piles have revealed surfaces made of drifting stones and porous dust, ancient construction sites from the dawn of the solar system, barely held together after billions of years. Mercury hides a giant metallic heart. Though Mercury is small, most of its interior is dominated by an enormous iron core, proportionally larger than any other rocky planets. Scientists debate how this happened. Perhaps a colossal impact stripped away its outer layers, or perhaps the young sun's heat favored heavy materials. Whatever the cause, Mercury is a world with a thin crust and a massive metal heart, quietly orbiting closest to the sun. Venus is a world without a moon. Among the inner planets, Venus alone travels without a companion in the sky. Its lack of a moon adds to its mystery. Perhaps one existed long ago, only to fall inward or be lost in a collision. Perhaps Venus's slow backward rotation makes stable orbits unlikely. Whatever the truth, Venus drifts alone, wrapped in clouds, with no lunar glow to break its eternal twilight. Gas giants gather families of moons. The farther you travel into the outer solar system, the more satellites you find. Jupiter and Saturn host dozens, worlds with oceans, mountains, volcanoes, and frozen plains. Uranus and Neptune carry clusters of icy moons as well, each shaped by the quiet tug of gravity. These moons are like small solar systems within our solar system, complex, ancient, and full of stories that have yet to be read. Hubble watches the planets from Earth's doorstep. Though it orbits only a few hundred kilometers above Earth, the Hubble Space Telescope has given us breathtaking views of Jupiter's storms, Neptune's dark spots, Saturn's seasonal shifts, and Mars's changing surface. From its quiet perch, Hubble observes not only distant galaxies, but also the familiar worlds of our own system, watching their weather, rings, and colors change year after year. Jupiter's great red spot is a storm with centuries in its voice. This vast, swirling vortex has raged for at least 350 years, perhaps longer. It has gradually shrunk, but still remains powerful, with winds that exceed 400 kilometers per hour. Imagine a storm so vast it could swallow multiple Earths, turning endlessly in a world of clouds and lightning. Jupiter's storms do not age the way ours do. They persist like old memories, still alive in the present. Neptune shines with its own inner warmth. Despite its distance from the Sun, Neptune radiates more than twice the energy it receives. Something inside, contraction, leftover heat, or radioactive decay, keeps the planet restless. This internal energy drives the fast winds and swirling storms that cut across its sapphire atmosphere. Neptune's calm blue color hides a deep, quiet power. Earth alone carries water in all its forms: ice, liquid, vapor. Our planet cycles all three across its surface and sky. This balance is delicate, shaped by our distance from the Sun, the weight of our atmosphere, and the movement of water between sea, cloud, and snow. On Earth, water moves, evaporates, freezes, melts, dances with weather, and cradles life. No other known world carries such a complete, living cycle. The heliopause marks the edge of the Sun's reach. Far beyond Pluto lies a boundary where the solar wind slows and gives way to the pressure of interstellar space. This is the heliopause, the frontier where the Sun's influence fades. Voyager 1 and 2 crossed it, stepping into the true space between stars. Beyond this boundary, the solar system's breath ends, and the galaxy's begins. Triton is a moon stolen from the cold. Orbiting Neptune in the opposite direction of the planet's rotation, Triton gives itself away. It wasn't born there. It was captured, likely from the Kuiper Belt, dragged into orbit by Neptune's gravity, disrupting any moons that may have been there before. Triton's geysers of nitrogen gas rise through thin frost, and dark streaks mark where these plumes fell back to the surface. It is both an outsider and a resident, a wanderer pulled into a new life around a distant world. Neptune carries 14 moons, each with quiet tails. Some moons orbit close and fast. Others drift far and slow. Many are irregular, captured objects from the early solar system. Most reflect almost no sunlight, making them faint and shadowy bodies circling a blue giant. These moons form a scattered family, stitched together by gravity. Each a relic from a part of solar history we can only guess at. The Parker Solar Probe touches the Sun's outer breath. Human-made objects were once confined to Earth's skies. Now, a small spacecraft is diving into the Sun's atmosphere. Protected by a heat shield that glows white-hot, the Parker Solar Probe flies through the corona, the Sun's outermost layer. measuring magnetic storms, electrical currents, and plasma waves. With each orbit, it draws closer, moving faster than any human-made object in history. It doesn't simply observe the sun, it swims through it. Pieces of Mars fall to Earth. Some meteorites discovered on our planet carry the chemical signature of Martian air trapped inside them. These rocks were thrown off Mars long ago by powerful impacts, drifting through space for millions of years before falling onto Earth's surface. They are natural messengers across space, samples of another world delivered without intention, offering clues about Mars long before robots could roam its deserts. The sun is mostly made of the two lightest elements, hydrogen and helium, simple, abundant, ancient. They dominate the sun's mass, shaping everything it does. In the sun's core, hydrogen fuses into helium, releasing the energy that lights our days. The remaining elements, oxygen, carbon, nitrogen, and metals, are only a tiny percentage, yet they arise from the ashes of older stars. Even our star is a child of others, carrying their remnants within its glow. Earth's tilt is the quiet architect of seasons. With a tilt of about 23.5 degrees, Earth leans just enough to give meaning to time. This tilt determines which hemisphere receives sunlight, shaping spring, summer, autumn, and winter. Without it, the world would be locked in monotony. No blooming springs, no shifting winters. This subtle angle influences migration, weather, and the rise and fall of ecosystems. A small tilt with an immense effect. Jupiter's magnetosphere is the largest structure in the solar system. If it were visible, Jupiter's magnetic field would stretch wider than the sun in Earth's sky. Charged particles caught within it dance in spiraling paths, creating intense radiation belts and spectacular auroras. This magnetosphere shapes the environment of Jupiter's moons, affecting their surfaces, their oceans, and even the chemistry of their atmospheres. It is a giant's shadow, invisible but powerful. Planetary rings are temporary, delicate sculptures. Rings around Saturn, Jupiter, Uranus, and Neptune are not eternal. They form from shattered moons or captured ice and dust, then slowly fade as particles drift inward or escape. Saturn's rings, despite their beauty, may only be around 100 million years old, a recent development on cosmic timescales. One day, they will vanish entirely. The rings we marvel at are a momentary shimmer. The moon's surface barely changes through time. Without wind or rain to erase them, footprints from the Apollo missions still lie untouched, as crisp as the day they were made. Craters from ancient impacts remain sharp-edged. The moon is a museum of scars, a place where time slows to a near standstill. Only tiny meteorites and soft space weathering alter its features. Some icy moons may hide warm underwater vents. Europa, Enceladus, and perhaps even Ganymede or Callisto may hold oceans warmed by energy from their rocky cores. These oceans could host hydrothermal vents like those on Earth. vents that support life without sunlight. If similar systems exist on these distant moons, the ingredients for life may be simmering in darkness, untouched and waiting. Sunlight needs 8 minutes to reach you. Light begins in the sun's core, where it may spend hundreds of thousands of years bouncing through dense layers. When it finally reaches the surface, it leaps across space in just over 8 minutes. Each sunrise is a message delayed, light that began its journey long before your day began. You've traveled so far tonight, from the warm glow of the sun to the drifting edges of interstellar space. You've moved gently through storms, oceans, rings, shadows, and silence. And now, here you are, resting at the very edge of everything we know. A quiet place where the solar system softens into the dark, where stars breathe slowly in the distance, and where nothing asks anything of you. Take one slow breath. Let your shoulders sink. Let your thoughts unfurl like dust settling in the softest beam of starlight. You've done enough. You've heard enough. You've traveled enough. Now the universe can hold the rest. Tonight, you've wandered through worlds that burn, worlds that freeze, worlds that whisper, and worlds that dream in silence. And still, through all that wonder, the peaceful rhythm of your own breath has carried you gently forward. You've drifted beside ancient moons and suns older than memory. But right now, the only thing that matters is the calm settling in your mind. You are safe. You are warm. You are held. Even as planets turn, as comets wander, as galaxies drift through their slow spirals, there is space, infinite space, for you to rest. You don't need to solve or fix or chase anything. You don't need to be anywhere else. This moment belongs only to you. Let the weight of the day slide away. Let the stories of distant worlds fade into a soft glow behind your thoughts. Let your breath grow deeper, slower, softer, like the dimming light of a star at the end of its long journey. And if sleep is already beginning to wrap around you, let it. You've earned it. Thank you, truly, for being here, for listening, for traveling with me through quiet light and deep shadowed orbits. It means more than you know. You stayed with me until the very last moment, and I hope you feel how special that is, how special you are. So for now, rest your mind, rest your heart, rest your body. The universe will still be here in the morning. Sleep well, dream softly, and may the quiet stars watch over you tonight.